Welcome to the deep dive. Get ready to have your mind blown today because we are diving into a connection that seems like straight out of science fiction, but I promise you it's not.
It's going to be a wild one.
We're talking about the mind-boggling world of cosmology, black holes, the Big Bang, all that good stuff. But we're connecting it to something surprisingly familiar, AI.
Yeah.
The AI that's learning to write poetry and predict the weather.
And what's even wilder is we're not just talking about some like casual link or
Yeah,
analogy.
right.
There's actual research suggesting the way these AI systems learn through something called neural networks
Uh-huh.
might be surprisingly similar to how a universe evolves.
Okay, you lost me at similar to how a universe evolves. I mean, I love a good sci-fi flick as much as the next person, but
Yeah.
how can something as complex as the universe possibly be, like learning how to play chess or whatever?
You're right to be skeptical. That's what makes it so fascinating. It all starts with this idea of duality in physics.
Dual.
Yeah, think of it like this. Imagine two video games that look totally different. One's a fantasy epic, the other's a futuristic space opera, right?
Hmm.
But under the hood, they're actually running on the same basic code, same set of rules.
Okay, I'm starting to get the analogy, but how does that apply to like the actual universe?
Well, researchers are finding that the way a neural network learns those complex systems that power AI might actually be described by very similar math to how the universe itself expands and evolves. Specifically, they're finding parallels between how these networks learn and the behavior of something called a scalar field in the early universe.
Hold on, scalar field. You're going to have to break that down for me.
Sure. Imagine a giant weather map of the universe, but instead of showing temperature, it shows the energy level at every single point.
Yeah.
That's basically what a scalar field is.
Okay, so instead of looking at individual stars and planets, we're zooming out to this energy landscape of the universe.
Got it.
But how does that relate to AI?
Here's where it gets really interesting. You see, right after the Big Bang, the universe was thought to be dominated by a specific kind of energy field, vacuum energy. It's a bit of a mind-bending concept, but essentially it's energy that's woven into the very fabric of space-time itself.
Right, like that cosmological constant thing that Einstein supposedly called his biggest blunder, but then it turned out to be a thing.
Exactly. Now, what's incredible is researchers are finding that the equations that describe how this vacuum energy, this scalar field, evolved in the expanding universe are shockingly similar to the equations that describe how a neural network learns through something called gradient descent.
Wait a minute, you're saying the way my phone learns to recognize my face, which still feels like magic to me, by the way, is somehow mathematically similar to how the universe itself expands and changes over time? My mind is officially blown.
It's pretty wild, right? And the implications are huge. One of the most exciting findings is that a neural network's learning rate, basically how quickly it learns, might directly correspond to the cosmological constant, that fundamental value that governs the expansion of the universe.
Okay, let me get this straight. You're telling me there might be a direct link between how fast a computer program learns and one of the fundamental constants driving the behavior of the entire universe.
It seems crazy, but that's what the math seems to be pointing towards.
Whoa, we're already in pretty deep territory, but I have a feeling this is just the tip of the iceberg, right?
You're telling me. This research is suggesting some truly mind-blowing possibilities. What if we could simulate the universe using AI? Or use our understanding of cosmology to build entirely new, more powerful AI systems?
Are we talking about creating a mini Big Bang inside a computer? Because I am here for it.
It's not quite a mini Big Bang, at least not yet.
Yeah.
But you're on the right track. Researchers are already starting to test these ideas by using AI to simulate simplified models of the universe.
So they're basically creating a digital sandbox to see if these cosmic connections hold up.
Precisely. And what's even more encouraging is that the early results are looking good. They're seeing this eerie alignment between how the neural networks are predicted to behave based on this duality and what actually plays out in the simulations. It's still early days, of course, but it's incredibly exciting.
I bet. But those simulations, they're still pretty basic, right? I mean, we're talking about recreating the vastness of the universe and everything in it with AI. It seems like a long shot.
You're not wrong. Right now, these simulations are using simplified models of both neural networks and the universe itself. To really push the boundaries of this duality, we need to see if it holds up with much more complex systems. Instead of just that single scalar field representing the early universe, imagine simulating an entire web of interacting forces and particles, the kind of cosmic dance that leads to the formation of galaxies and black holes.
Now that is what I'm talking about. Simulating the universe on that scale, though. It's hard enough to wrap my head around, let alone program into a computer.
Exactly. Even with our most powerful supercomputers, simulating the universe at that level of detail is a massive challenge. But that's where the real potential AI comes in.
Hmm.
Imagine being able to train a neural network on the fundamental laws of physics, and then essentially setting it loose to see what emerges.
It'd be like watching the universe fast forward through billions of years of evolution right before our eyes.
And not just watching. We could test different theories, explore alternate scenarios, really unlock the secrets of how the universe we see around us came to be.
Okay, I am officially on board with this plan. Build the cosmic AI stat. But let's not forget about the flip side. You mentioned using cosmology to improve AI. What does that look like?
Well, think about it. The universe is inherently chaotic, unpredictable, right? Yet from that chaos emerges incredible complexity and structure,
Hmm.
galaxies, stars, planets. It all arises from this dance of randomness and order.
And are you saying we can program that kind of cosmic creativity into our AI?
That's the big question, isn't it? Maybe instead of just feeding AI massive data sets, we can build in some of these cosmic rules, this inherent randomness and uncertainty that somehow leads to greater complexity. It's a radical idea, but the potential is there to create AI that's less reliant on brute force computation and more adaptable, more capable of true learning and innovation.
So we're not just talking about smarter AI, but fundamentally different AI that learns and evolves more like, well, the universe itself. I love it.
And it gets even wilder. This whole line of research is raising some seriously profound philosophical questions.
Okay, now you're speaking my language. Hit me with those deep thoughts.
Well, if the way the universe evolves can be described by math, that's eerily similar to how a neural network learns, what does that say about the underlying nature of, well, everything? What is information? What is computation?
Are we living in a simulation? Is the universe just one giant computer running a cosmic algorithm we haven't cracked yet?
Those are questions that physicists and philosophers have been grappling with for centuries. And this research throws fuel on that fire. It's both exhilarating and a little terrifying to think about.
Exhilarating and terrifying, you say. You're definitely speaking my language. But seriously, where does it leave us all this talk of universes and AI and the fundamental nature of reality? I don't know about you, but I'm still trying to process all of this. We've gone from AI writing poetry to simulating the birth of galaxies to questioning the very fabric of reality.
It's a wild ride for sure.
Yeah.
But that's the beauty of cutting-edge research, right? It forces us to confront the biggest questions and challenges our assumptions about how the universe works.
So, where do we even begin to unpack all of this? What are the key takeaways for our listeners who might be feeling like their brains just went through a black hole?
I think the biggest takeaway is that we're on the verge of a paradigm shift. For centuries, we've separated the study of the cosmos from the world of information and computation. But this research suggests they're deeply intertwined in ways we're only just beginning to understand.
So it's not just that we can use AI to study the universe or vice versa. It's that there's a fundamental connection between these two realms that could unlock completely new avenues of discovery.
Exactly. This isn't just about building better telescopes or faster computers. It's about expanding our entire framework of knowledge and questioning the very tools we use to understand reality.
It's like we've been handed a treasure map, but instead of leading to buried gold, it points to something far more valuable, a deeper understanding of the universe and our place within it.
And the most exciting part is this is just the beginning. The research we've discussed today is still in its infancy. There are so many unanswered questions, so many avenues for future exploration.
So what's next? Are we going to have cosmic AI predicting the future? Or using black holes to power our smartphones?
I wouldn't rule anything out. But in the near term, I think we'll see a surge of research to more complex simulations. Can we use neural networks to model not just the expansion of the universe, but the formation of galaxies, the behavior of black holes, the very emergence of life itself?
It's like opening a door to a whole new universe of possibilities, both literally and figuratively.
And that's what makes this such an exhilarating time to be alive and curious about the universe. We're witnessing the convergence of fields that were once thought to be completely separate, and the insights we gain could reshape our understanding of everything from the smallest subatomic particle to the grand structure of the cosmos.
So to our listeners out there, keep your minds open, your curiosity piqued, and get ready for a future where the lines between AI and the universe we inhabit become increasingly blurred.
It's a future full of wonder mystery, and the potential for groundbreaking discoveries that could redefine what it means to be human in a universe that's more complex and interconnected than we ever imagined.
And on that note, we'll leave you to ponder the infinite possibilities. Until next time, happy deep diving.